A database is a structure for storage of information that allows for the retrieval of data at a later stage in time. Different databases use different sort of structures, and therefore different structures are best suited for various kinds of information. In this video, we'll be taking a look at some of the different types of database structures available to us and the main difference between the various structures available. A relational database was a database created around the concept of mapping datasets conceptualized by Edgar Frank Card at IBM in 1970. The relational database uses a concept of organizing data into tables, columns, and rows. Each table would be considered a category of data to be stored. Each row is a field or attribute which describes what is being stored about that category, and a row is an entity, namely stating that each row is its own different object in a sense, containing its own unique data. Tables and rows in a relational model are referenced together via the use of things called primary and foreign keys. Now, a primary key allows each row in a table to uniquely identify, and is required to be unique. A foreign key links to the primary key of another table, allowing two tables to interact based on linking the foreign key assigned here to the primary key of the other table, essentially merging data together, but only ever by the use of queries and joining. Here we see two tables of a MySQL database that is linked together via a primary key and a foreign key. The primary key of the first database being the student ID, and the primary key of the second database being the subject ID, linked together on the student ID. When it comes to the advantages of a relational database, one major such advantage is that such a database is scalable. It can be easily edited without modifying existing records in place. With the amount of time that the relational database has been around, many security implementations have already been developed to keep your data as safe as possible. Standard query language can be used to retrieve data from the database quite efficiently given the knowledge to do so. The structure of such a database is quite easily understood, and a person can typically see such a database and know immediately what it is meant for. The disadvantages, however, are that the relational databases lack the support for complex data types such as images and videos that many applications and websites require in the modern day. When accessing complex queries and data types, SQL makes it quite difficult to obtain the data required, such as the need for thousands of joins to obtain one piece of data. Data that needs to be stored must be known beforehand, thus all fields that will be possibly stored must be pre-planned and added to the database in order to be inserted, unlike with a no-SQL database. A relational database becomes quite useful in the event that data stored is not in vast quantities and the data being stored is simple and not complex types. Small companies with a limited number of clients and transactions, as well as the typical applications that need to store average amounts of data, should make use of this as their primary method of database operations. An object-oriented database is a database that stores objects rather than data as individual relations. It makes use of object-oriented languages such as C++, Java, and C#. Objects consist of the attributes as well as executable methods on that object in order to query data. One of the most important things about an object-oriented database is classes, which defines the way in which an object is structured. Objects can have inheritance relationships with other classes, allowing one object to contain the data of another object as well as the data of the new object inheriting. With such a structure, one could consider classes as tables and objects as rows. We can consider the attributes defined as fields and the methods within them as a form of conveniently accessible stored procedures. Each object contains a unique ID and thus can be used to access each other. Here we can see two shape objects, line and circle, which inherits from a parent shape object called L-shape. Both of these objects contain another object called C-point, which contains the coordinates for each object. In this method, we can easily access different parts of different objects. An object-oriented database has reduced paging, which in technical terms means less calls and overhead made to the system. The navigation is made much simpler using objects, as accessing something requires only finding the object of the thing you are looking for. Concurrency in databases is also made simpler with objects, as it can treat the object as a whole rather than individual data items. The structure is also based more on how we see and perceive things in the real world rather than how we try to make it fit in the database. The disadvantages, however, comes with the greatly reduced efficiency when working with simple data, and the less tools and support offered by the object-oriented database versus the relational database. An object-oriented database becomes useful in the event that the data being stored is of a complex type. When things such as images and videos are stored in a database, they become something called a blob, which is a binary large object and a funny name for a data type. When handling blobs, SQL becomes an inefficient method of accessing things such as parts of a video, such as specific frames, etc. Due to this, the quicker access and easy manipulation of the object structure becomes a useful tool in achieving goals. The no-SQL database was designed due to the increase in the volume of data stored about entities. Unlike in a relational or object-oriented database, there is no predefined outline for inserting data, and thus almost anything that needs to be stored can be stored without the user needing to know about it in advance. Thus, development becomes faster and less time is needed on database administration. NoSQL databases support a feature called auto-sharding, in which the data is automatically spread across a number of servers, and the application is not required to know about all these servers. This allows for quick, easy, and transparent maintenance if a server had to crash, causing no interruptions to the application. For this example, I'll be using a NoSQL database called Neo4j, which is a graphing database which treats every single object as a node. These nodes can be linked together in different weird ways, allowing for storage of almost any kind of object you desire. The biggest advantages come in the fact that NoSQL database can easily handle and manage large volumes of data that other databases might struggle to handle. It has quick iteration over data and also makes use of the object-oriented approach, giving it similar advantages of such a database. It has support for automatic replication of data and it has a much higher disaster recovery rate than most other databases. The software, however, is open source and therefore little support is available for it, unlike big-name relational databases and such. It has very few features allowing for ad hoc queries, and data consistency becomes harder to maintain in a NoSQL database. When data becomes abundant and large, standard queries become too difficult and slow to perform. Thus, NoSQL was developed as a means for storing large amounts of seemingly strange data, as in the example of social media sites, where millions of users have constantly fluctuating data with quick need for access. The term data warehouse was coined by William H. Inman, who is known as the father of data warehousing. A data warehouse is a system used more for reporting and analysis. A data warehouse is a storage of information from multiple sources that is collectively gathered in order to calculate information needed, usually things such as yearly income, company costs, etc., and is a very important part of the data mining process in industries. There are two approaches to a data warehouse design. The top-down approach, which creates spin-offs of data marts for specific user groups after the warehouse has been created, and the bottom-up approach, which builds the data marts first and then from there creates an all-encompassing data warehouse that contains all the necessary information required for analysis. In this example, we can see how the operational systems all come together to form one giant warehouse which contains the metadata, the summary data, and the raw data, which can then be sent out into different data marts for purchasing, sales, and inventory, which are treated as their own databases and handled by analysis, reporting, and mining individually. The advantages lie in that multiple databases can be congregated into a single location in order to use one set of query and procedures on it. You can maintain the data history even if the source systems did not, and create a single data model for all data of interest even across multiple data sources. Query processing of multiple types is available, and you can also restructure data so that it makes more sense to the business user. The disadvantages lie in the initial implementation time as well as the high cost involved in creating and maintaining a data warehouse. The data ends up becoming static and dated and becomes a larger problem for business modules which rely on a constantly shifting data. It becomes extremely difficult to accommodate changes in data types, ranges, data source, indexes, and queries, and the data owners lose control of the data, leading to problems with ownership, privacy, and security. Data warehouses are expensive and take a long time to initially set up. Therefore, data warehousing becomes a resource for big companies and the data mining industries that require centralized access to all their data as efficiently as possible.